Okay, so today we're going to go over the law of sines in section 12.4. So there are a couple things that you need to add on to the notes where there are blanks. They don't have it completed. So looking at your first page, the key concept, area of a triangle. The area of a triangle is 1/2 the product of the two lengths of two sides and the sine of their included angle. So let me draw the triangle. And if we start with angle A, the side across from angle A is always side A. So your angle is an uppercase A, and the side is a lowercase a. So then we have, sorry, that stuff is on there. Angle B is at the top, so side B is across from that, and then you have angle C and side C across from that. Okay, so the way you can set this up, you need to know two sides and an angle. So your area is going to be 1/2 side B times side C and the sine of angle A. So it's two sides and then the angle that's in between them. And you can use any two sides in as long as it's the angle in between the two sides. So if you are using side A and side C, side A and side C, then you would use the sine for angle B. And then the last possibility, if you're using side A and side B, here's side A and side B, you would use the sine for angle C. And that would give you the area. So let's look at the first example. Find the area of triangle ABC to the nearest tenth if A is 31 degrees, side B is 18 meters, and side C is 22 meters. So I'm just going to label this triangle that we already have drawn. Angle A is 31 degrees, B is 18 meters, and C is 22 meters. So to get the area, I'm going to take 1/2 times 22 times 18 times sine of 31 degrees. So we're going to type that into the calculator. .5 times 22 times 18 times sine of 31. And they want us to round it to the nearest tenth. So since it's 101.977, the area is going to round to about 102 square meters. So you want to make sure and include that unit of measure if they give it to you. Okay, any questions? So let's move on to the next key concept. And the next key concept is the law of sines. So in triangle ABC, if sides with lengths A, B, and C are opposite angles with measures A, B, and C respectively, then the following is true. And so your law of sines is saying that you have ratios that are equal to each other. You have the sine of angle A over the side A. That's the same ratio as sine of angle B over side B. Same ratio as sine of angle C over side C. And that works for any triangle. It doesn't have to be a right triangle. It's good for anything. So if you know three values, any three values for your triangle, you can figure out everything else. Well, you have to have at least one angle or at least one side. Any questions? All right, so let's look at example 2. Solve triangle NPQ if angle P is 42 degrees, angle Q is 65 degrees, and side N is 5. So let's draw the triangle for that. P is 42 degrees, Q is 65 degrees, and the side N, which is across from angle N, is 5 units long. So I know the side across from angle Q is side Q, and the side across from angle P is side P. So to use my law of sines, I have to know an angle and the side across from it. So what do I need to solve for first before I can do anything else? Angle N. So I need to figure out what that measurement is. What am I going to do to solve for angle N?
Subtract the other two angles from 180.
Right, a triangle totals 180. So I'm going to take 180 minus 65 minus 42. And angle N is 73 degrees. So now I can solve for one of the sides. It doesn't really matter which one. So I'm going to solve for Q. That means I'm going to use angle Q in my law of sines. Okay, so sine of 73 over 5 is the same as sine of 65 over side Q. And we're just going to do our cross products. And I'm just going to calculate it out. It doesn't say what to round to, but I'm going to round, for the side measurements, I'm going to round to the nearest tenth. We got 5 times sine of 65. And I'm going to take that decimal, divide by sine of 73. And I'm getting that Q is about 4.7 units.
So why'd you switch the 5 and Q? Why'd you put them on the different sides?
I did cross products.
Okay.
Yeah. Because it's a proportion, so you can do that. Okay. All right, so when they tell you to solve the triangle, they mean find all the things that are missing. So we still need to solve for P. So I'm going to use the sine 73 over 5 again because those are exact answers. I don't want to use something that I've rounded because that's going to make my final answer for my other side a little bit off. So I'm going to use the exact numbers that I know. And that's going to be equal to the sine of 42 over side P. So we'll do our cross products again. 5 times sine of 42. And divide that by sine of 73. And I'm getting about 3.5 for that side length. Is everybody else doing okay? Any questions? Okay, let's go on to the next page. These are possible triangles when you have two sides and one angle. So this is telling you how to determine if the measurements that you're given in a problem actually make a triangle or not. So let's look at the key concept. On this top row, I'm not going to look at the angles if they're right or obtuse. Let's just look at if the angle is acute, the angle that they give you. The side across from it is going to be your side A, okay, for your angle A. and then B is adjacent to angle A. And in this printout, they're using H, which is like your height, but the measure of H is B times sine A. So you probably need to write that down somewhere near that key concept so you'll know that you need to calculate B times sine A to get the value of H. So if angle A is acute and A is smaller than B times sine of A, there's no solution. There's not going to be a triangle. The sides aren't long enough to meet. If A is equal to B times sine A, then you will have one solution. Now down here, they have B is greater than A is greater than B times sine of A. If that's true, it says that it's no solution, but that's wrong. It is two solutions. So you need to correct that. And then your last scenario is if A is greater than B. So this time they're not even working with B times sine of A. They're just comparing A and B. So if A is bigger than B, you're going to have one solution. All right, over here on the obtuse side, if angle A is obtuse and side A is less than side B, there's no solution. If side A is greater than side B, then you're going to have one solution. So after you figure out if you're actually going to have a triangle or not, then you can solve for the rest of the sides and the angles that are missing. Okay, so let's do a couple of examples. Now one thing you need to notice is the setup here, they're using angle A, side A, and side B. So when the triangles that they're giving to us, angle name and side name, if they're the same, that's like your angle A and side A. So let's do A for an example, and I'll show you further what I mean. You have triangle RST. Angle R is 95 degrees, R is 10, and S is 12. Okay, so I have angle R and side R. They have the same name. So this is like your angle A and side A in the examples from the key concept. And then whatever side is left over, that's your side B. It doesn't matter what letter it is, that's just side B. So first you want to look at the angle measurement. This is 95 degrees. Is that going to be obtuse or acute? You guys remember? Obtuse, right. Obtuse is anything over 90. Acute is anything less than 90. So since it's obtuse, I just have these two possibilities right here. If A is less than B, there's no solution. If A is greater than B, there's one solution. So let's look at the side lengths. A is 10. B is 12. So A is less than or equal to B. So that means from your key concept that there's no solution. And since there's no triangle, then you can't solve for anything else, so that's going to be your answer. Any questions?
Why is it less than or equal to?
What do you mean?
Like, how do you...
On the sheet, it's less than or equal to. And that's what I'm going by.
Oh, okay.
Yeah. Okay. All right, so let's look at part B. Triangle MNP. N is 32 degrees. Side N is 7, and side P is 4. So angle N and side N are like your angle A and side A, and then the last side is B. This angle is acute, so I have 4 possibilities to pick from. Okay, the first thing that you want to look at is it going to be that side A is greater than or equal to side B? Because that's the only one that does not involve the B times sine A. to figure out. So let's look at if side A is bigger than side B. And if that's the case, then I can just say, well, there's going to be one solution. Okay, so side A is 7, side B is 4. A is greater than or equal to B. That does work. So you're going to have one solution. That means I need to solve for the rest of the triangle. So I'm going to draw the triangle since it actually exists. And label the vertices. Angle N is 32 degrees. Side N is 7, so across from angle N, that's going to be 7. And side P is 4, so across from angle P is 4. We're going to use the law of sines to solve for my unknown parts. So what should we solve for first? Angle P. Okay, sine of 32 over the opposite side equals sine of angle P over that opposite side. And I can do my cross products. So I'm going to get my decimal. 4 times sine of 32. And I want to divide that by 7. So I'm getting that the sine for angle P is about 0.3028. I'm going to carry it out a few decimal places. So I actually want to solve for the angle. Okay, and this is the sine for the angle. So to calculate that, do you guys remember what to do? What button do you use on the calculator? You don't use just the regular sine button, right? You use the second function, yeah. So I'm going to press second function sine so that on the graph or on the calculator it has to the -1 power. It has that little inverse sign. And then I'm going to type in 0.302811. And the angle is about, I'm going to round it to the nearest degree. So angle is about 18 degrees. So on the triangle, that's 18 degrees. So now I can find angle M. I take 180 minus 32 minus 18. And that last angle is 130 degrees. Now I just need to solve for side M. So I'm going to use the ratio that's exact. I don't want to use sine P over 4 because I had to round it, and that's going to throw your last answer off even more. So I'm going to use the exact values they give me in the problem. And use sine of 130 over side M. So we can do our cross products. And I'm getting that side M is about 10.1. So those are your answers. Any questions? Is everybody good? Okay, I'm going to turn this over. And we're going to look at the last scenario, part C. Triangle ABC. Angle A is 47 degrees. Side A is 15. And side B is 18. So we need to determine if this is going to actually make a triangle. First of all, we have an acute angle. So I'm going to be using all of these on the left side. A is less than B. on this one, they're actually giving us A, B, and C, which that's kind of nice. So A is less than B. The only scenario that works with is this third one. So what I need to do is check B times sine A and see if A is bigger than B times sine A. So 18 times sine of 47. And I'm getting about 13.2. So it is, A is bigger than B times sine A. So we are going to have two solutions. There's two possibilities. So what I'm going to do is I'm just going to divide the paper, and I'm going to have answers for one solution on the left side, one possibility on the right side. Excuse me. So let's start with just the regular, sine 47 over side of 15 equals sine of angle B over side B. We're just going to figure out what this one is, just normally. So I want to do my cross products. And since I'm solving for the angle, I have to use that inverse key, right? The second function. So let's type that in. And then divide that by 15. So my decimal is 0.8776244. Okay, so that's about your sine value for angle B. So now let's calculate the angle measurement. Second sine, and type in that decimal. And I'm getting that angle B is about 61 degrees. Okay, so if angle B is 61, then I want to also solve for angle C and side C. Angle C, I'm just going to take 180 and subtract 61 and subtract 47, the other two angles. So angle C is 72 degrees. And then solve for side C. Do the cross products. And I'm getting that side C is about 19.5. Does that sound good? Alright, so the other scenario is if angle B is obtuse. Here, angle B is acute, but angle B could be obtuse. So to find my other scenario, I'm going to take 180 and subtract the angle that I got the first time, 61. So that means that angle B could be 119 degrees. And then we're going to find angle C by taking 180 minus 119 minus angle A, which is 47. And so angle C is about 14 degrees. And we can solve for the side C. Use sine 47 over 15 equals sine 14 over side C. And let's do the cross products. So I'm getting that C would be about 5 if you rounded it to the nearest tenth.